In this lesson, we are going to learn about synthetic division, which is a fundamental, easy-to-use tool for finding solutions of not only quadratic equations, but also polynomial equations of higher degree as well. Let's get started with example 1, in which we are required to use synthetic division to find the remainder and quotient. Here the given polynomial is given polynomial is x4 minus 10x square minus 2x plus 4. This is a polynomial of degree 4 and the term x cube is missing. In fact, if we want to use synthetic division, we should always rewrite the polynomial including the missing term with 0 coefficients so that there is no confusion. Here we can write this as 1 times x4 because x cube is missing, so we're going to include that term. 0 times x3 minus 10 times x square minus 2 times x plus 4. And the polynomial on which we are going to divide this polynomial is x plus 3. So that polynomial is x plus 3, and this must be written in the form like negative should come after the variable x. So x minus negative 3. So that we are clear which number we have to use for division purpose while using synthetic division. Here let's write down these coefficients: 1, 0, minus 10, minus 2 and 4. And let's divide this with minus 3. So draw the line here and bring down the first coefficient 1. And once we bring down this coefficient 1, just below the line, underneath 1 itself, this will be 1. And at this point, we are going to multiply minus 3 with this number and write the answer below the next number. So negative 3 times 1, the answer is minus 3, that we are going to write here, and add 0 and minus 3 will get minus 3. We repeat the same thing. Negative 3 times negative 3 would be 9, and minus 10 plus 9 would result in minus 1. Again, every answer has to be multiplied back to the same minus 3. Negative 3 times minus 1 is equal to plus 3. Here we have plus 3, and negative 2 plus 3 is equal to 1. Negative 3 and times 1 is negative 3, and the answer is 1. This last number what we have is in fact the remainder. So here remainder is equal to the last number. It is 1. If remainder was equal to 0, then minus 3 would be called root of this polynomial. And here quotient starting from right, excluding that last number, this 1 is the constant term. So if 1 is the constant term, then the next term in ascending order will have coefficient minus 1. So plus minus 1 times x, so that would be the next term. And what would be the next term in ascending order? The next term would be x square, which will have minus 3 as coefficient. So this would be minus 3 x square, and next term in the ascending order is 1, which is 1 times x cube. Therefore, we found the remainder equal to 1 and quotient equal to x cube minus 3x square minus x plus 1. This is the quotient when x4 minus 10x square minus 2x plus 4 is divided by x plus 3 by using synthetic division. If remainder was equal to 0, then x plus 3 would be called factor of the given polynomial, or minus 3 would be called root of the given polynomial. Now the next question here is, if x plus 1 and x minus 2 are factors of x cube plus px square, x cube plus px square, so x cube plus px square plus qx plus 1 or plus 2, px square plus qx plus 2. So if this is plus 2, and we know that x plus 1 and x minus 2 are factors. So this is given polynomial. Is equal to this. Since x plus 1 and x minus 2, since x plus 1 and x minus 2 are factors, if these are factors, then when we perform synthetic division on this polynomial by minus 1 and 2, the remainder must be equal to 0. So let's get started with the procedure. So this is example number 2. Here, writing the given polynomial in descending order because there is no term missing, so this will be 1, p, q, and 2. If we divide this by minus 1, if we divide this by minus 1 because x plus 1 is a given factor, so if we divide by minus 1 and bring down this 1 here, minus 1 times 1 would be minus 1, and this would be p minus 1 by adding up p and minus 1, and negative 1 times p minus 1 would result in minus p plus 1. And if we add it up, this would be q minus p plus 1. And if we multiply again minus 1, so this would be minus q plus p minus 1. And upon adding, we would have p minus q plus 1. Because 2 and minus 1 will result in plus 1. But this last number must be the remainder. Since x plus 1 was the factor, since x plus 1 is given factor, is given factor, so p minus q plus 1, so p minus q plus 1 must be equal to 0. And let's call this as equation number 1. And we perform the same procedure on the quotient, what is left behind, that is 1 p minus 1. And so the quotient is 1 x square plus p minus 1 x plus q minus p plus 1 as a constant term. And now we will perform the same synthetic division over this polynomial of degree 1 less than the given polynomial. So here the coefficients are 1, p minus 1, q minus p plus 1, and the other polynomial given is x minus 2. So this time we are going to divide it by 2. The same way we draw the line and bring down 1. 1 times 2 is 2. So let's write that down here. So this would be, if we add p minus 1 and 2, this would be p plus 1. And 2 times p plus 1 would be equal to 2p plus 2. And now if we add these up, the answer is q plus p plus 3. And because this is the last element, so this must be the remainder. And since it was given, since x minus 2 was given factor, so q plus p plus 3 must be equal to 0, because that is the remainder, and factor always leaves the remainder equal to 0. So this is, let's call this as equation number 2. Solving equation 1 and 2. Solving equation 1 and 2. So what was equation 1? Equation 1 was p minus q plus 1. P minus q plus 1 equal to 0. So that was equation 1. And this is p plus q plus 3 equal to 0. This is equation number 2. Simply add them up by adding. We have minus q and plus q are cancelled, so 2p plus 4 is equal to 0. This means 2p is equal to minus 4 and p is equal to minus 4 over 2, that is equal to minus 2. Substituting this value of p in equation 2 or 1, whatever you want to use, substituting this value of p in equation 2. So this would be minus 2 plus q plus 3 equal to 0, means q plus 1 equal to 0 means q is equal to minus 1. We'll see you in next lesson with more questions.